Hello everyone. Welcome to this technical AMA for Genius Yield, where I will try to answer all the technical questions we have collected from you. First, I want to talk about what trading strategies SLVs, smart liquidity vaults, will follow and how flexible they are. So SLVs, or we also call them two-way orders, actually exist in 4 different modes along 2 different axes. So one axis is one-way versus two-way. The other axis is flexible price versus fixed price. And actually they are supposed to replace the existing so-called partial orders that we have. That is when they are used in fixed price one-way mode, and they are supposed to be a replacement for liquidity pools on AMM DEXs, in which case they would be used in two-way mode and flexible price. But there are also these other 2 modes, one-way flexible or two-way fixed price, which are maybe less useful. So one-way versus two-way, an SLV is always with regard to a specific token pair. So there are 2 tokens potentially in it. And one-way means trades can only happen in the one direction and only the one token will be in there. So if we take ADA gens as an example, and for example, the direction is from ADA to gens, then one way would just be like a classical limit order on our DEX. So somebody places an order by putting ADA in, and then people can take ADA out and paying gens to the creator of the order. And then at any point, the creator of the order can cancel the order and gets the remaining ADA back, or all the ADAs can be filled, in which case automatically the order is closed. So that's basically the classic limit order behavior of our so-called partial orders that we have on the DEX right now. And two-way would mean that you can put one or both tokens in, and it doesn't matter which ones. So in this example of ADA gens, you could put ADA in when you create the order, you could put gens in when you create the order, or you could put both in arbitrary ratio. And then trades can happen in both directions. So somebody can take ADA out and put gens back in. So in that case of two-way orders, true two-way orders, the payment doesn't go back to the order creator, but goes back into the order itself, into the SLV, and also other way around. So somebody could take gens out and put ADA back in. So that's why we call them two-way orders. So they exist in these 2 modes, one-way and true two-way. And the other axis is fixed price versus flexible price. So fixed price is like it is now. You specify a specific price. So if somebody takes one ADA out, how many gens does he have to pay? If somebody takes gens out, how many ADA does he have to pay? So in the case of one-way orders, that's just one price. In the case of two-way orders, that would be 2 prices. I mean, of course, normally the 2 prices would be related. One would be the reciprocal of the other, but obviously that doesn't have to be the case. So that can be specified. And the flex price means it's tied, it's relative to the market price. So we use an oracle that determines the market price, and then instead of specifying a fixed price, for example, I don't know, 0.01 ADA per gens, you say something like 2% above the market price. And it's actually a bit more flexible than that, so you can give this spread in percent, so and so many percent above or below the market price, but you can also specify an offset. So first add this number to the market price and then take a certain percentage. So that's the 4 modes or flavors of SLVs that we have. And they are just in other regards, they are not like normal orders. So it's not like staking where there is a lock period or anything. So you can place them, people can fill them, and the creator of the order can at any time cancel them. The difference is in this one-way order, as I said before, if they are completely filled, they are automatically canceled, whereas a two-way order has to be explicitly canceled. So until it's canceled, before it is canceled, it stays on the blockchain and people can use it in both directions. So that's the first version of SLVs that we will release, where basically the strategy is restricted to these fixed prices or relative prices at a specified spread around the market price, modified by a given offset. The next question is about oracles. What oracle will the SLV use? So as I explained, there is this flexible price option where the price at which an order is filled depends on the current market price. And in order to get the current market price, of course, one needs some sort of oracle. And the design of the smart contract itself is flexible. So basically, on the smart contract level, if an order is created, you just specify the public key of the oracle. And then at fill time, in order for the fill to happen, in the redeemer, there has to be included a certificate that's signed by the oracle and specifies the 2 tokens, specifies a timestamp, and specifies a price. So in principle, the order creator could use arbitrary oracles that provide these certificates. However, at the moment, there is no suitable third-party oracle on Cardano that has a price that would make it feasible to use them for this scenario. So to start with, we will provide our own centralized oracle. So by default, when you create an order, there will be a public key address belonging to Genius Yield, noted down in the order datum as the oracle provider. And then when you want to fill an order, Genius Yield will look up the current market price using several providers for redundancy and to make sure that the price is correct, and then sign these certificates. So that's sort of a point of centralization, but it's only a first step. So we hope that in future there will be more decentralized options. And of course, everything is fully visible on the blockchain, so the whole world can see which prices we certified at a given time. So if we make a mistake, then it's obvious to everyone. So we will be very careful to not make mistakes. And as I said, in future, this can be extended. So either we could use third-party Oracle providers, or ideally we could use mechanisms like, for example, Uniswap and Ethereum. They provide their own Oracle. So they use their own trading data of their own DEX to determine a market price. At the moment, for us, that's infeasible because the trading volume is so low. But of course, in future, that hopefully will change. And then we can think about things like that, where it's a truly decentralized Oracle based on smart contracts. Alternatively, we could also maybe do something similar for other DEXs on Cardano, like Minswap or SunnySwap, and somehow directly on the smart contract level use their prices to inform our Oracle. But as I said, in the first version, it won't work like that. It will just be this centralized certificates signed by Genius Yield. Third question, how will SLVs compare to AMM models like Minswap, and which will be superior in practice? So of course, which will be superior in practice remains to be seen, but obviously we wouldn't do this if we weren't optimistic that the SLVs will be superior. So AMMs first manifested by Uniswap on Ethereum have this beautiful, simple idea, right? So there's this constant product formula, and for somebody to provide liquidity, all you have to do is pick a token pair like ADA gens. Of course, in the case of Ethereum, it will be different tokens, and put both of them in a specific ratio proportion into a so-called liquidity pool. And the proportion between the two quantities of tokens determines the price, the current price. And then after you have done that, you, as a liquidity provider, you can just walk away. And from that point onward, each time somebody wants to trade these two tokens, that automatically happens. So, and the price will automatically be adjusted based on this constant product formula, so that the product of the two quantities always has to be constant, or rather, it always increases with each trade a little bit, and that's exactly the fee or the yield that is the incentive to provide liquidity in the first place. So in each trade, some of the amount of tokens grows. And then after a while, the liquidity provider can come back and retrieve his liquidity and the accumulated yield. So the advantage is it's really very elegant and simple. So all you have to do is deposit those two tokens and then don't do anything. And then hopefully when you come back after a while, you have made a profit. You have earned some yield. Well, even on Ethereum, there are problems with that, at least two problems, I would say. One is it's not very flexible. Everybody follows the same strategy. So this amount by which the constant product has to grow is like fixed. It's a protocol parameter, more or less, I think. And so there is no trading strategy. Everybody follows the same strategy. There's no flexibility. You can't do anything clever. It's just this one way how everything works. Then there is the problem that because of this product formula, the whole price range from 0 to infinity is covered. And that means that a lot of the liquidity that you put into a pool actually doesn't do any work. So it just sits there and is inert, whereas basically only the liquidity that's concentrated around the range of prices that where the current market price actually fluctuates in, only that is basically put to work. So that means your liquidity is not really utilized fully. A lot of it sits in parts of this hyperbola that gives this constant product formula that is inert and is never used, which means you basically earn less yield than you should, given the amount of liquidity that you provide. And then there is, of course, one of the biggest disadvantages, in my opinion, that Ethereum has over UTXO blockchains like Cardano. That's indeterminism. So on Ethereum, if you submit a transaction, one thing that can happen is it fails, but you still have to pay gas fees. Or it can succeed, but then you don't know what the outcome will be. So in the specific example of a liquidity pool, in one block, several trades can happen against the same liquidity pool. And depending on the order in which these transactions will be processed by the blockchain, you get a different price. And that's why DEXs like Uniswap have to introduce this concept, so-called slippage, where when you place an order, because you don't know what exact price you will get, because you don't know at which point in time your order will be processed, you have to provide a sort of so-called slippage, where you say, okay, if the price changes in this interval, then I'm okay with it, then go ahead. Otherwise, I don't want you to proceed with my order. So that means you don't know exactly what price you will get. And this is actually one of, for me, the most beautiful things about Cardano or UTXO blockchains in general, that it's completely deterministic. So on Cardano, if you submit a transaction, it can fail, but in that case, you don't have to pay anything. But if it succeeds, you know exactly what the effect will be. So in the case of a DEX, for example, normally you know exactly how much money you will spend and how much money you will get from this specific transaction. However, when you try to move the Ethereum model of this constant product formula AMM DEX one-to-one to Cardano, then you have the problem that you could only do one trade per liquidity pool per block. So let's say for ADA gens, you can only have one trade every 20 seconds on average. And that may be fine if volume is low, but of course it doesn't scale. And in order to mitigate that, what DEXs like Minswap have done is they introduced the concept of batchers. So instead of users directly interacting with the liquidity pools on Cardano, they post UTXOs that are more like an intent to trade. So instead of actually doing the trade, the transaction doesn't perform the trade. It just basically signals on the blockchain, hey, I want to sell so many gens or buy so many ADA. And then there are these batchers or scoopers that are normally operated by the DEXs, and they collect all these trading intents and batch them and then process them in bulk in one transaction. So that solves the scalability issue. So now it's possible to have many trades per block on the same token pair, but it introduces indeterminism because now, again, the order in which you are included in such a batch matters. So again, even though we are on Cardano where everything should be deterministic, it isn't. So you have the same effect that you have on Ethereum, that you don't know when you place an order what price you will get. So you again need the slippage concept. So that's like in my opinion, the pros and cons of AMM DEXs. So the pro is the simplicity, the cons are the inflexibility, basically no different trading strategies, and the indeterminism, the slippage. Now, if you look at order book DEXs, it's sort of like a mirror image. So we don't have this problem of that liquidity just sits inert at price ranges that are unrealistic because we have like specific prices. So the liquidity is always exactly concentrated at the market price or close to the market price and is put to good use. So that is very nice. And we fully embrace the UTXO model. So we don't have like one global liquidity pool UTXO per pair. We have individual orders, and each of these orders is a UTXO. And in principle, in one transaction, not in one transaction, but in one block, there can be interactions, trades on all of these orders simultaneously. So there's potential for massive parallelism, which is much closer to the spirit of the UTXO model than the AMM idea. And it's also simpler because we don't need these batchers because there is no need to batch. The orders can be processed individually. And you know exactly what you get. So when you create an order to fill, you create a transaction in order to fill an order, then you know precisely what price you will get. So the concept of slippage just doesn't apply. But on the flip side, it's much more complicated. So and that is also sort of like in the real world. I mean, order book DEXs are much closer to how real world stock exchanges work than AMM DEXs. And in the real world, people like you and I probably would never have the idea to provide liquidity for like the New York Stock Exchange because you have like specialist companies that do that. So financial experts that have to be highly trained and experienced to actually make money with that. And the issue is twofold. I mean, at the first place, you need like expertise in order to know what you're doing. I mean, where to place orders. And then when the market price changes, you have to reposition orders. So if you wanted to do that on our DEX in the past, I mean, you could place orders around the market price, but then if the market price changes, you had to cancel orders and reposition them, like recreate them at different prices. And you had to rebalance. So, I mean, you can place buy orders and sell orders, but if then at some point there is an imbalance between your tokens, and then you have to maybe cancel some and somehow reshift the tokens and so on. So that means in order to do that efficiently, you need time because you have to constantly monitor what's going on the DEX. You need some sort of financial expertise in order to know at what prices to place these orders. And you need some technical know-how in order to do that. Or at least if you don't want to sit in front of your computer all the time. So, I mean, what we did in order to mitigate that was created these so-called liquidity bots that were supposed to do that automatically. And we open sourced that so that in principle everybody could run that. But that was tedious, right? Not only tedious, but you also had to be somewhat technical versed and you needed the infrastructure to do that. So it was complicated to do this. And now the idea of the SLVs is to basically exactly fix that problem. So to take the best of both worlds, to take the simplicity of providing liquidity on AMM DEX and combine it with the other advantages of an order book DEX. So to make it simple to provide liquidity while keeping all the other advantages of an order book DEX, like concentrated liquidity and parallelism, determinism. So that's why we are very optimistic that SLVs will indeed be superior because they combine the nice ideas or the advantages of both concepts. Are SLVs primarily a technical or commercial innovation? I think it's both. I think in my previous answer, I already explained why it's commercially interesting because it sort of combines the simplicity of the AMM approach with the advantages of the order book approach and concentrated liquidity, determinism, more flexibility in trading strategies and so on. So that's why I think it's commercially interesting and lucrative. And technically, it also solves a lot of issues that we had with our previous concept. I mean, our previous so-called partial orders worked fine as long as you are just looking at individual users that want to do a handful of trades. But when it comes to bots, for example, like liquidity providing bots, then there was this technical limitation that you could only place one order per transaction on our DEX. And that had technical reasons related to NFTs that mark valid orders and so on. So not only was it, I mean, time consuming, because if you wanted to place several orders, you had to like do that one after one. So it took like several blocks to do that. It was also expensive because you had to pay transaction fees each time. So there we technically innovated and made that much better. So now you can place a lot of orders in one transaction, also fill them and cancel them. So I think that's the biggest progress on the technical side, that now if somebody wants to handle multiple orders at once, then that's cheaper and faster. I mean, for like users that use the DEX UI directly, that won't really be visible because there you anyway just place one order at a time or cancel one order at a time or fill one order at a time. Although filling, that's not completely true, because if you use the market order feature, then under the hood, several orders may be filled. But anyway, place one order at a time or cancel one order at a time, so that won't change. But especially for bots, for example, there's a massive advantage now that it's much faster and cheaper. So I think in that sense, it's a technical advancement. What will AI integration with SLV mean for users? First of all, I think the question we should ask is not restricting it to SLVs, but to the DEX in general, AI integration with the DEX. Well, when Laurent, our founder, first approached me about the Genius Yield idea, he had like two things that were important to him. One was making things simple. So he felt that it was much too complicated for ordinary people to use DeFi. So he felt you have to be some sort of finance expert or technical expert to work with DEXs. So he wanted something simple, intuitive to use. And the second thing, he had this idea to use machine learning to optimize yield. And that's basically what Genius Yield started to develop, like an intuitive DEX that is empowered or optimized with machine learning. And of course, back then that was before the era of LLMs. So the idea was that we develop our own machine learning tools to actually achieve that. But I've also always said in interviews that before we can even think about machine learning and the yield optimization, we must first have the DEX, because before you can optimize something, you must first have something that you can optimize. So that's why in the beginning we concentrated all our efforts on the DEX. And then we ran into this liquidity providing issue that I alluded to in my previous answers, that even though theoretically, because of concentrated liquidity, determinism, flexibility, and so on, order book DEXs should be superior to AMM DEXs. In practice, because it was so complicated to provide liquidity, it wasn't like that. And therefore, our DEX has always been suffering from a lack of liquidity. And we couldn't even begin to think about developing machine learning tools that do that. However, I mean, while this was happening, revolution has happened in the world of machine learning. So now we have ChatGPT and LLMs in general. And that was, at least for me, like totally unexpected when a couple of years ago we set out to develop Genius Yield. So now I think this is a great opportunity for us to get what we originally were aiming for, both the intuitive use and simplicity and the yield optimization. So the idea is that instead of developing our in-house own machine learning solutions. We make it possible, for example, in the form of an MCP server for LLMs to interact with our DEX. In particular, of course, then also with SLVs. And that solves somehow both of these issues that from the beginning were like central to our mission. Because using something like ChatGPT, you can basically use natural language to make things happen on the DEX. I mean, in principle, you can just say, hey, go to the Genius Yield DEX and buy me 100 gens, or how much would I have to pay for 100 gens if I pay in ADA, and can you find me the best offer, and so on. So you just talk to the thing, and then it does what you want it to do. So it can't really get any more intuitive than that. And on the yield side, I mean, I personally don't know how good, for example, ChatGPT these days is with like asset management. I mean, I certainly haven't tried to get investment tips from ChatGPT yet. But I mean, one thing we can be sure of regarding LLMs is that they improve at an incredible speed. So even if they are not really good at investment right now, then probably in half a year or in a year they will be. So the beauty of this new way of combining Genius Yield with AI via this generic protocol, for example, an MCP server, is that we automatically profit from all the advances in AI. So whenever AI gets smarter, better at money management, better at investment, as long as AI can interact with our DEX, we profit automatically from all these advances. So I expect in future, I mean, in the not too far future, probably AIs, LLMs will be superior to humans when it comes to investment. And at that point, because we have this integration between Genius Yield and AI, you can just tell ChatGPT, please optimize my yield on the Genius Yield DEX. And then that's that. And you don't have to think about it. And you will get more yield than you would if you try to do it yourself. So I think that's the way to think about that. So, I mean, somehow we got overtaken by history. So the LLM revolution happened, but it means that we can concentrate fully on like the DEX part and can just piggyback sort of on the advances in AI, as long as we make sure that AI can talk to our DEX, understand what it offers, and interact with it. What have been the biggest challenges during SLV development? I think it was mostly to create something that encompasses the functionality of our existing partial orders and offers this new functionality, basically stand-ins for liquidity pools on AMM DEXs, and do everything in a way that's fast, simple, and cheap. So I mentioned before that with the existing partial orders, you could only create one per transaction. And now with the SLVs, you can create several per transaction, which in particular for like power users and bots makes it cheaper and faster to quickly like reposition themselves on the DEX. And for that, you need all sorts of technical tricks that we weren't aware of or that hadn't been developed 2 years ago or when we wrote the original smart contracts. So to somehow get something that is strictly more capable and powerful than the existing smart contracts, because it, instead of this one existing mode, has now the 3 additional modes, and does it faster and cheaper and allows you to batch more like actions in one transaction. And to do all of that, I think that was the biggest challenge. Why did Order Book DEXs underperform and how has Genius Yield adapted? So I think I've basically already answered that in my previous answers, but just to recap, I think the reason is that they are more complicated to work with, Order Book DEXs, at least on the liquidity provider side. I think for users that just want to use the DEX, use existing liquidity, there's no notable difference in how difficult or easy it is to use, whether you go to Minswap, for example, or to Genius Yield. But I think there's a clear difference, or used to be a clear difference, when it comes to providing liquidity. So we often had people coming to us, investors that were happy or willing to provide liquidity, but then they were basically scared off when they heard what that entailed. And as I explained before, it's sort of like in the real world, like with New York Stock Exchange, that until now you needed basically a specialist, either a finance expert or like a technical specialist that in order to provide liquidity efficiently. Plus, as I also explained, because of this thing that, for example, you could only create one order per transaction, it was relatively expensive to reposition your positions, which also didn't make it very lucrative. So how did we adapt? Or I mean, first we try to provide liquidity ourselves. So we have these liquidity bots, and so we provide liquidity ourselves. But obviously that wasn't ideal. And as I said, there were people that wanted to provide liquidity, and so we wanted to make it easy for them. And I mean, that was either a technical or a legal problem. I mean, legally, I mean, we could of course have told people, give us your money and we provide, I mean, we put it on the DEX. But that obviously is a legal can of worms because then we have custody of other people's money. So that was a no-go. And then the idea that we pursued was to make it easy for people to run their own liquidity bots. So we open source this liquidity bot framework and try to make it as easy as possible for people to use it. But I mean, it would still entail to run, for example, a cloud instance where you can actually run these bots, or to keep your own laptop running 24 hours. And of course, you needed some sort of technical expertise to be comfortable with like configuring such a bot and running it. So I think that was the biggest issue, that it wasn't easy to do it, and it also wasn't clear how lucrative it was, and or if it was lucrative at all. So people were not highly motivated to jump all these technical hurdles to actually do it. And I think now with the SLV approach, that is the better way to do this, because now it's as simple as it is for an AMM DEX. So it's just a matter of putting money. It's even simpler, arguably simpler, because on AMM DEX, as I explained before, you need both sides in the right ratio. For example, ADA gens, you need both ADA and gens in the right ratio that's dictated by the current market price. And with the SLVs, you only need ADA or gens or both in arbitrary ratio. It's more flexible because you can determine your own spread. So it's, I mean, you have an influence on it, but it's also not complicated. It's basically just one number that you have to provide, but as simple as on AMM DEX. And at least in theory, more lucrative because you have this concentrated liquidity. So your liquidity should work harder for you to earn your yield than it does on an AMM DEX. So I hope that this is now the right way to approach this liquidity problem, and I hope that that will provide the boost that Order Book DEXs need to fulfill their full potential. Now let's move away from the topic of SLVs and talk about whether reward distribution and dust conversion could be automated. So the reason it hasn't been automated is that, at least in the beginning, after we introduced this new distribution system, we were experimenting with various incentives and ways to incentivize trade on our DEX. And almost every week we had like new ideas how to incentivize certain behavior. So the rules changed all the time. And because, I mean, the new distribution system that we're using is extremely flexible, so we can basically apply arbitrary rules to distribute arbitrary tokens to arbitrary people. But that also means it's all not just a simple config file, it's code. So all these rules are encoded in Haskell in our case. That means if there's like a new initiative to change something, tweak something, how rewards work, or provides extra incentives, or like we did switch from APY-based staking rewards to revenue sharing, all these things require code changes. So therefore, we didn't automate it because we didn't. I mean, if you automate it, it's more difficult to change. I mean, as it is at the moment, basically it's me. So if a rule changes, I just fix the code quickly and do it. If you automate it, then it's running on some server in the cloud, and then it becomes more complicated to automate it. So it's certainly possible. It's just that there was never enough stability to actually do it because the rules kept changing. I mean, that being said, I think now we are at a point where the rules don't change so much anymore, so we can certainly revisit that and do it. But another important point is also that it's not just a technical question, right? I mean, the things that we distribute must come from somewhere. So it's not just about running a script. It's also about making sure that the tokens that need to be distributed are actually available. And of course, in the case of revenue, that's automatically there. I mean, that's also the beauty of revenue sharing because it's so sustainable. So if the DEX is doing well, there's a lot to share. If it's not doing well, there's little to share. So the revenue, by definition, is always there. But I mean, there are still like legacy APY staking vaults floating around. So we still need like tokens coming from somewhere. And like part of the weekly distribution is to make sure that those tokens are actually there, ready to be distributed. So you can never, at least as long as that's the case, you can't fully automate it because somebody must make sure, I mean, must tell somebody, hey, send me these tokens. I need to distribute them. So that's another reason why we haven't done it yet. But I hope we can change that in future. And regarding dust conversion, I think, I mean, it's certainly possible. And I think it's also an interesting problem. And there's different solutions to it, potential solutions. I mean, the easiest would be to just provide a button that basically creates a market order on our DEX, where you can, with one click, basically under the hood, create market orders to convert all your dust into ADA or gens or something. That's probably the easiest way, but it's probably also not interesting really because I mean by definition it's only called dust if it's small amounts, and if every single user that wants to convert this dust into, let's say, ADA has to create market orders for that, then probably the Cardano transaction fees alone would eat up all the value of these dust tokens. So then, of course, one could think of alternatives, like, for example, people can, like each person, each user can decide whether he wants to receive his rewards in, like now, as a bag of tokens, or in a specific currency, like ADA or gens. And then, I mean, one thing that's we could conceivably do is basically collect all the rewards, all the dust from all the users that don't want to receive that dust, and then like trigger market orders in bulk. I mean, for all of this combined. So then it would, I mean, all the dust together would be like a significant amount. So the fees, the involved fees would not be so bad anymore. And then we could just distribute the results. So that's one idea I had how we could potentially do that. Of course, it's always a question of priorities. I mean, what is more important, SLVs or dust conversion? But of course, if the demand for that, I mean, if enough people want this, then it's certainly technically possible. Will you be using Starstream with Atlas PAB, and how will they complement each other? Well, we don't have any concrete plans to do that, but it's certainly obviously interesting. I mean, to combine zero knowledge proof capabilities with what Atlas can do is certainly interesting. I mean, one problem obviously is the technology um, clash because I mean Atlas is Haskell and Starstream is not. But obviously that is like a problem that could be solved if the incentive to do so would be big enough. And I mean, I mean, I haven't thought about this deeply, but I mean, zero knowledge proof offer like I mean, help in two areas. I mean, one is privacy, so you can do, I mean, prove certain things without revealing certain other things. And the other is that you can offload expensive computations to off-chain. And I think both, I mean, there are conceivable use cases for the DEX. I mean, on the privacy side, I mean, for example, there might be certain trading strategies that if you implement it without zero knowledge, basically the strategy itself would be visible on the blockchain in the datum, for example, and maybe that would sort of make it unattractive to actually use such a strategy because then everybody can see your strategy. So, I mean, that's a vague statement, but I mean, it's conceivable for me that privacy and zero knowledge might be useful in that context. And then, as far as expensive transactions are concerned or expensive calculations, I mean, one thing, for example, I mean, where I noticed that is with the distribution system, that is not smart contract based. So basically, when one of our users is withdrawing their rewards, then we have like a piece of code running like off-chain that checks whether, I mean, how much money this user is actually, I mean, how many rewards that user has accumulated. And obviously, the first idea that I had was to do that with a smart contract. And I mean, I don't want to go into too much technical details. So, I mean, there's a lot of data because there are hundreds of thousands of recipients with all sorts of tokens, and you can use something like Merkle trees. So I did have an implementation for that that would have been completely smart contract based. But then under certain combinations, if there were like lots of different tokens being distributed and so on, it turned out that we ran into these limits, memory execution units. So the smart contract would have run, I mean, wouldn't have fit into a transaction on the blockchain. So that is, I think, a typical case where zero knowledge proofs can help. So if one wanted this badly enough, to do this reward distribution in a smart contract, then one could use something like Starstream to do this off-chain, these calculations, and then just put the proof in the transaction. So there are certainly use cases. And of course, I mean, when things become more complex, when we want more complex strategies, trading strategies, orders that can do more things, then of course this becomes maybe more and more important, this aspect, that it's possible to put expensive calculations off-chain. But again, there are no immediate plans to use it, but I'm certainly not opposed to looking into zero knowledge proof strategies as soon as we have a need for that. Next question, can we expect UX and front-end improvements? I mean, sure, we are permanently tweaking the UI and the UX, and we try to. And obviously, when we notice that there's a pain point, that things are confusing for our users or could be easier, then obviously we would do our best to fix that. I do, however, think that especially in light of what I said earlier about AI, maybe these things are no longer as important as they used to be. So, I mean, I've heard speculations that maybe in a few years, the traditional UI will be gone and we basically interact with the internet always via something like ChatGPT, and the AI will basically create a UI for us on the fly that's optimized for what we try to achieve right now. Of course, I don't know whether that's true, but it sounds plausible to me. So maybe the time where one has to put a lot of energy and time into UI design is almost over, and we are close to a future where UI will be created on the fly by AIs for us. But nevertheless, of course, we are not there yet. So until we get there, of course, we will try to um, make our UI as intuitive and as simple to use as possible. But obviously, there are always trade-offs to be made. And of course, if you have to decide whether you implement SLVs and try to solve the liquidity problem or whether you make the color scheme more pleasant, then obviously the SLVs are more important. But I'm not saying that UI can't be important or isn't important. Just that, of course, you always have limited resources and must somehow put priorities. What would a smart liquidity vault version 2 look like? Well, as I discussed before, at the moment, the flexibility is very limited. So it's basically just sell high, buy low at a configurable spread around the current market price. And obviously, an obvious idea would be to make that more flexible and enable better strategies. Another improvement that I can think of, I mean, I mentioned the Oracle before, and I already said that one not so nice point about this new SLV design is that for the time being, we have the centralized Oracle provided by Genius Yield itself. So another obvious way to do a version 2 would be to provide a truly decentralized Oracle, ideally based on our own trading data, or at least based on maybe the top 3 Cardano DEXs trading data or something like that. And the third direction, of course, is AI integration. And that might actually trump the first thing I mentioned. So instead of making the smart contracts more complicated and flexible and allow more complicated trading strategies, maybe the better way is actually to fully embrace this integration with AI and then just let AI take care of complicated trading strategies. Obviously, this is not completely straightforward because you have to figure out how to actually do that in a secure way so the AI doesn't steal your money and so on. But nevertheless, I think that's maybe the most interesting direction to evolve this. That and maybe getting a more decentralized Oracle. What can we expect from the Bitcoin integration and what is the roadmap for that? Well, I think in the case of Bitcoin integration, it would be stupid for us to try to build our own custom bridge to Bitcoin because IOG is working on something called Cardinal, which is a fully decentralized Bitcoin bridge, and they already have demonstrated a prototype and successfully moved assets from Bitcoin to Cardano. And this will hopefully be released very soon. As I said, it already exists as a prototype, so it's only a matter of time until that exists. So I think it would be, as I said, stupid for us to try to compete with that, and it would also not make sense. I mean, why would we want to have our own bridge? Because, I mean, as soon as Cardinal is operational, then all projects on Cardano can profit from this influx of liquidity from Bitcoin. And so therefore, I think as far as GNC is concerned, we should just wait until the Cardinal bridge is available and then fully make use of it. So make it as easy as possible for people coming from Bitcoin to do DeFi on the Genius Yield DEX by making it as seamless and smooth as possible. I mean, for Charles, Charles always points out that for Bitcoin people, they don't want to even think about or know about other blockchains. So they want to stay in their Bitcoin world. And so that would be the obvious thing to try to achieve with Genius Yield as well, to make it very easy for people coming from Bitcoin, bringing liquidity from Bitcoin to use the Genius Yield DEX without having to bother about Cardano terms, basically. I think that's the best we can do by using the IOG technology, Cardinal, the bridge that's coming, and then making use of all the liquidity that will be coming from Bitcoin and just making sure that it's as smooth and easy to use as possible. What are possible future catalyst proposals that Genius Yield could submit? Well, I mean, first of all, I'm very pleased that in the last round, the options proposal has been approved because that's sort of my baby. So I've did this prototype 2 years ago or so, or maybe even longer ago, and I'm very keen to actually see it in action because I think it will be really added value to Cardano DeFi to have these options. Anyway, so of course we also had like 2 proposals that were not approved, real world assets and somehow making Atlas play nicer with Bitcoin. So obviously, an obvious choice would be to try to maybe reframe those 2 proposals and resubmit them. But also in the course of this AMA, we have talked about a lot of future directions, right? An improved Oracle for the SLVs, AI integration, more flexible trading strategies. So all of those are are, of course, directions that we probably should go and where we should apply for catalyst funding. The last question is about pre-scheduled quarterly AMAs like this one. And I'm all for doing quarterly AMAs. I think this is really useful and was a pleasure for me to answer your technical questions. And I'm happy to do this every 3 months or so. As for pre-scheduled, I'm skeptical because in my line of work, I never know where I'll be a month from now, let alone 3 months from now. I mean, I have to travel a lot and there are always things coming up. So, and I hate breaking promises. So I would hate to pre-schedule something and then have to cancel it because Charles wants me to be in Singapore or whatever. So therefore, I'm skeptical about that. But I'm totally happy with like committing to this general cadence of 3 months, and then not commit to a specific day, but just say, okay, we do it every 3 months, and whether it's on the Monday or the Tuesday, that depends on circumstances. I hope that will work for you. Anyway, that's I think the last technical question that we collected from you. So thank you for asking them. Keep them coming, and thank you very much. And looking forward to the next AMA. Thank you.